Okay, if you've ever gazed up at the winter night sky, chances are you've spotted them. You know, that tiny, shimmering cluster of stars that looks like a miniature dipper? That's Messier 45, the Pleiades, but most of us know them as the Seven Sisters. And for basically all of human history, we thought we had them figured out.
I mean, this star cluster is an absolute icon. It's sitting there in the constellation Taurus, about 440 light-years from us, and it's one of the most recognizable things up there. Seriously, cultures all over the globe have been telling stories about these stars for thousands of years.
Well, get ready for a twist, because with the incredible new instruments we have today, astronomers are discovering that this old familiar friend is way more complex and, honestly, way more mysterious than we ever gave it credit for. The entire map of the Pleiades, yeah, it's being completely redrawn. So where do you even start? Well, the first big hurdle is just figuring out who's actually part of the family. Think about it. It's like trying to take a cosmic census, where your subjects are trillions of miles away and surrounded by a crowd of strangers. You see, the Pleiades is what we call an open cluster. The best way to think about it is like a bunch of stellar siblings. They were all born from the exact same massive cloud of gas and dust, and now they're all kind of loosely held together by gravity, cruising through the galaxy as a group. But here's the tricky part, right? When you look in their direction, you're not just seeing them. You're seeing them against this huge backdrop of countless other stars that have absolutely nothing to do with them. So how in the world do you tell the real members of the Pleiades from all these celestial photobombers? Well, the secret is to watch how they move. Stars that are actually part of the cluster, they all travel through space together, kind of like a flock of birds flying in formation. This diagram shows it perfectly. Each arrow is a star's motion, and you can clearly see that big clump in the middle, all heading in the same direction. That's what astronomers call common proper motion. And this is where a mission called Gaia has just been an absolute game changer. Gaia is the space observatory that is meticulously measuring the positions, the motions, and the distances to billions of stars. It lets astronomers build these mind-blowing 5D maps that's position, distance, and motion, allowing them to just perfectly pluck the true cluster members out from the background noise.
So, the big question, how many sisters are there really? Turns out, the name is a little off. A huge study in 2019 using all that juicy Gaia data identified, get this, 1,248 official members of the cluster. So not 7, over 1,200. But here's the coolest thing about science. When you get better data, it doesn't just give you neat and tidy answers. Oh no. It lets you ask much bigger, much more complicated, and way more interesting questions. And believe me, the Pleiades is at the heart of some serious scientific debates. For years, astronomers have argued back and forth about its exact distance, even its age. Is it a stellar toddler at 70 million years old, or more of a teenager at 130 million? But the latest data has kicked off an even more dramatic debate. Back in 2019, one team looking at the Gaia data made a shocking claim. They said they found evidence of this huge tail-like structure of stars being pulled away from the cluster. Their conclusion? The Pleiades was literally being ripped apart, dissolving into the Milky Way. But then, just in 2023, another team, using even newer and more precise Gaia data, went looking for that exact same tail, and they couldn't find it. Their paper basically said, nope, we don't see any tail. So what gives? Is the cluster dying, or is it perfectly fine? And you might think this sounds like a mess, but it's not. This is the absolute heart of the scientific method. It's supposed to be a little messy. This back and forth, this debate, it's how we get closer to the truth, with each new data set and each new analysis pushing our understanding forward. This is progress in action.
So while everyone's arguing about whether the cluster is falling apart on the outside, another group of astronomers has been peering deep inside the cluster, and what they're finding is just as mind-blowing. Because it turns out that when we look at one of those stars in the Pleiades, well, a lot of the time, we're not actually looking at just one star. There was this massive 40-year-long survey that painstakingly studied the light from these stars, and their conclusion was staggering. At least 57% of the stars in the Pleiades are actually binary systems. That means two stars orbiting each other. Just let that sink in for a second. More than half of the stars we call the Seven Sisters are actually pairs of stars, locked in a gravitational dance. The sky up there is just filled with twins.
Now, why is that so important? Because that number, 57%, is nearly double the rate you find for similar stars that are just floating out there on their own in the galaxy. This is a huge clue that tells us the crowded, chaotic environment where these stars were born plays a massive role in how they end up pairing off.
Okay, so let's recap. We've got a cluster that might or might not be getting shredded from the outside. And on the inside, it's packed with dancing pairs of stars. To really get the full picture, we have to look at one last thing. How is the cluster behaving as a single coherent system?
And this chart is beautiful. It's showing us the rotational speed of the stars. It's not random at all. You see the red dots? Those are stars moving toward us. The blue dots? They're moving away. What you're looking at is the signature of an organized system that's rotating around a common center. The Pleiades isn't just a random clump. It's spinning. In fact, when you run the numbers and model all this motion, you find a system that's in what's called dynamic equilibrium. It's all balanced. The inward pull of gravity is perfectly countering the outward motion of the stars in this stable, beautiful cosmic dance.
And here's the kicker. The latest, most detailed analysis of the cluster's motion shows no evidence that the group as a whole is either expanding or contracting. So while that debate about the tidal tails on the very fringes is still going on, the heart of the Pleiades, the core of the cluster, looks to be rock solid and stable. For now, anyway.
So the next time you're outside on a clear night and you see that tiny, misty patch of light, just remember what you're really looking at. It's not some static, unchanging painting on the wall of the sky. It's a living, breathing, spinning cosmic laboratory, packed with binary stars and holding on to secrets that we are just now, finally, starting to unlock. And it really makes you wonder, doesn't it? What else is hiding up there, right in plain sight?